Good morning, sir. Myself Harshita, bearing a roll number 244G580203 from Tripoli branch. So, in analog circuits, my topic is about a log amplifier. So, coming to the topic, first introduction to the log amplifiers. Log amplifiers are specialized analog circuits designed to output the logarithm of an input voltage. They are widely used in the applications requiring exponential scaling, such as signal processing and sensor interfacing. Understanding the principles of log amplifiers is essential for designing effective analog system. Here is a circuit regarding to the log amplifier. This is the non-inverting terminal. This is the inverting terminal. This is the diode fed from the output to the again to the non-inverting input. This is the feedback. Next, basic operating principle. Log amplifiers operate based on the logarithmic relationship between the voltage and current in certain semiconductor devices. The core component is typically a transistor or else diode configured in a feedback loop. The output voltage is proportional to the logarithm of the input current, allowing for the linearization of the exponential signals. This is the whole explanation about this logarithmic amplifier. Next, key component. What are the key components of the log amplifier means? The essential components of a log amplifier include an operational amplifier, a diode or BJT and resistor. BJT means nothing but bipolar junction transistor. The operational amplifier provides the necessary gain and feedback of the circuit. The diode of BJT is responsible for creating the logarithmic response based on the input current. So these are the characteristics of the log amplifier, which is this is the whole circuit. Next, circuit configuration. A typical log amplifier configuration involves an op-amp with a diode in the feedback loop. The input voltage is converted to a current via resistance which is fed into the diode. The output voltage is then taken from the op-amp, reflecting the logarithmic relationship between the input. This is the resistor which are placed between input voltage and this feedback. This is the non-returning terminal and is grounded to the earth. This is the diode or at a transistor. We can place diode or else a transistor in this feedback loop. Next, advantages of the log amplifiers. Log amplifiers provide a wide dynamic range, making them suitable for processing signals that vary significantly in the magnitude. They help to compress large signal variations into manageable output voltages. Their logarithmic response allows for the easier signal interpretation in applications such as radio or else RF systems. This is the advantages of the log amplifiers. Next, applications. What are the applications of the log amplifiers? Are commonly used in the audio signal processing to enhance dynamic range. They are vital in communication systems for detecting and processing weak signals. Other applications include analog to digital converter and measurement systems for physical quantities like light, sound. These are the applications of the log amplifiers. Next, coming to limitations. Log amplifiers can be sensitive to temperature variations which may affect their accuracy. They typically require careful calibration and component selection to ensure linearity over the desired range. Noise can also impact performance, making it essential to design for low noise operation in critical applications. These are the limitations of the log amplifiers. Next, design consideration. What are the design consideration of these log amplifiers means? The key design considerations including selecting the appropriate transistor or else diode for placing the feedback in the circuit for desired range and the response. The choice of the resistors in the circuit affects both gain and also bandwidth characteristics also. Ensuring thermal stability and minimizing noise are crucial for the achieving the reliable performance. Next, conclusion. What is the conclusion about the log amplifiers? Log amplifiers are powerful tools in the realm of analog circuits, enabling logarithmic response and signal compression. Understanding their design and operation is crucial for the engineers working with the diverse applications also. As technology advances, log amplifiers can continue to play a vital role in the signal processing and analysis. In case of analysis or signal processing, it is very important to the while signal processing. This is the core conclusion about the log amplifiers. Next, coming to the derivation of this log amplifier, this is a circuit diagram. We already know that one. Next, according to the assumptions, IB1 is equals to IB2 is equals to 0. Applying KVL at the node A, we can apply the KVCL at the node A. IR is equals to diode current plus IB2. In this way, we can say IB2 is equals to 0. IR is equals to ID. So we can this is the equation 1. Next, VA is equals to V according to the assumption. Next, apply KCL to the loop minus VA plus VD plus VC is equals to 0. In place of VA, we can place 0. according to this one we can place 0. So that's why we can draw this to the second equation. Next, applying KVL to the first input loop, minus V in plus IR into R plus VA is equals to 0. VA is equals to 0 means that IR into R is equals to plus V in, whereas in case of this IDA we can place IR is equals to V in by R. This is third equation. Next, according to the log amplifier general equation, this is the diode current Is into e power V naught by neta Vt minus 1. This is the general equation of the log amplifiers. Next, what is the ID? Diode forward current. What is Vd? Diode voltage. Ic, reverse saturation current. Vt, thermal voltage. Neta, ideality factor. Next, if neta is equals to 1, so n is equals to 2. Next, we can obtain the Q value is 1.6 into the power of 9 in coulombs. So the temperature is 300 kelvin. Next, Vt is equals to 25.8 millivolts. Id is equals to Is into this one. We can place Id by Is is equals to this. The e power coming to the in this part, we can apply the logarithmic I naught Id by Is is equals to Vd by neta into Vt. Next, Vd is equals to n neta into logarithmic Id by Is. So Vd is equals to minus V naught into minus V naught, that is equals to minus neta Vt logarithmic Id by Is. This is the output of the logarithmic amplifier or as log amplifier. This is the derivation about the logarithmic amplifier or log amplifier. Thank you, sir, for giving this opportunity. This is the whole presentation about my topic, that is which is logarithmic amplifier or log amplifier in the unlock circuits. Thank you.